Like the International Space Station itself, the STS-124 mission represents the spirit of global teamwork. Commanded by Mark Kelly and joined by JAXA astronaut Aki Hoshide, the crew of Discovery will build on the success of STS-123 by adding a large pressurized module and a versatile robot arm. STS-124 is the second in this series of flights. Discovery is in place on Launch Pad 39A, and the countdown clock is already ticking toward liftoff. Live from NASA's Kennedy Space Center, this is L-1.
Close and lock your visors and initiate O2 flow. It's time to fly.
Thanks for joining us here for our pre-launch show, L-1. I'm your host, Allard Beutel, News Chief here at NASA's Kennedy Space Center. L-1 is also NASA talk for the day before liftoff, and we are almost exactly 24 hours away from the launch of Space Shuttle Discovery. And we can feel the pace picking up here at the Launch Center as the clock is counting down. We've got a great show lined up for you today. We have veteran astronaut Mike Foale to take us inside the STS-124 mission that will dramatically increase the science potential of the International Space Station. But first, let me set the stage for you. This very studio is located inside the Kennedy News Center, and media from around the world have been pouring in the last couple of days to cover tomorrow's launch for a global audience. The hub of this activity is right across the street from here in the Launch Control Center, or as we call it, the LCC, which is really the brain of the shuttle launch complex. Every mission launched at Launch Complex 39 from the Apollo missions straight through the shuttle program has been controlled from firing rooms inside the Launch Control Center. Right now, there are controllers on duty around the clock monitoring the health of Discovery from Firing Room 4. It's a very exciting time to be here, and it's a very good time for us to introduce Dr. Michael Foale. Thank you for joining us.
It's a pleasure to be with you.
Well, when I call you a veteran, that's no lie. 6 flights, and including one on the long-duration flight on the International Space Station and a long-duration flight on the Russian space station Mir. You've gone through a few countdowns yourself.
Yes, I have.
What's it like?
Well, it's nerve-wracking. I was surprised, but I was able to sleep before each countdown. The night before, I got sleep. But once you get out there, once you get up, you've had your breakfast, you're part of a team, and you're aware of this team building you up, getting you ready, making sure you get out to the launch pad on time. They don't want anyone locked in the toilet or anything like that back home. And you feel some tension with your crewmates. As the Astrovan and Silver Van takes you out to the launch pad, you're aware that this day is very, very different from other days, because other days you've seen workers out there at the launch pad, just regular things are going on, the guard checks happen, the badges are checked. But this day, no one is out there. In fact, if there are any vehicles, they're all leaving the launch pad, and that's because it's a really dangerous place. And you're going out there, and it makes you think, this is the most dangerous place in the whole area, and you're driving out towards it. Once you get into the vehicle, you kind of settle down, and it's more familiar to you again. This is stuff you've trained in the simulator many, many times. And the countdown progresses in a fairly steady way over 2 hours to that magic moment, 2, 3, 2, 1, 0. And then the solid rocket boosters kick off.
And it really, is it like the training? I mean, do you kick back into your training mode, or it really does feel that extra special that this is real, not simulated?
The other big difference about actually driving out in the Astrovan to the launch pad is, of course, that you're not going to a simulator, you're going to the real thing. And so simulators, no matter how good the graphics, and our graphics in our simulators back in Houston are not as good as even the best games around these days. So when you actually get in a vehicle and you see sky through the windows, and you see blue sky, and you're on your back, and the smell of the vehicle is a little different from the simulator, and it's newer looking, and all that tells you this is different. And so, however, nonetheless, everything that you do is familiar to you because you've done it before in the simulator.
Well, actually, for this particular crew on Discovery, 2 of them are veterans, and 2 of them are actually experiencing a countdown for the very first time. So let's take a look at the STS-124 crew.
2-time shuttle pilot Mark Kelly takes the reins as commander of Space Shuttle Discovery on the 26th mission to the International Space Station. It's the first shuttle mission for crew members Ken Ham, Karen Nyberg, and Ron Guerin, and the second for Mike Foale. Aki Hoshide represents the Japan Aerospace Exploration Agency on his first spaceflight. Expedition 17 flight engineer Greg Shamatov will join the crew aboard the station, replacing Garrick Reisman, who will return to Earth after his stay in orbit.
Well, let's get to the part where we have the thing in the back of Discovery in the cargo bay, the payload as we call it. This is Japan's major contribution to the International Space Station. It's overall, the laboratory is called the Japanese Experiment Module, or GEM, or
Kibo, yes.
Or Kibo.
Means, I think hope, is that right?
Absolutely. And we're taking up the pressurized module, the biggest lab on the space. It will be the biggest lab on the space station and the biggest module we've ever taken up on it. Right now, we really have all the major scientific elements up on the station, or will be after this
Just
flight.
about, yes. This mission is key. It really, I think psychologically for the partners, it will be the accomplishment of the dreams of building an international space station and international experiment facility and laboratory. And Kibo Lab is the end piece. It's not the final piece, but I think psychologically it is.
And there have been people here at the Kennedy Space Center from Japan who have worked here since the pressurized module arrived. You yourself, obviously, having not only flown on the International Space Station, but on Mir, had to train and live in Russia for some time yourself. So what's it like having to immerse yourself into a different country and work with their space program?
Well, that's the neat thing about being an astronaut today, at least a government astronaut in the United States, is you get to meet all these other partner nations and their astronauts and their engineers and support people. It's a little tough for me as a scientist, physicist, who wasn't very good at languages initially in school, to have to learn Russian, for example. And I speak Russian really well now, fluently, and that's a result of many, many years of living in Russia and flying on the International Space Station. But all those new friends, that new experience is extraordinarily valuable to me personally. And I welcome the day when, and I met Koichi outside just now, when I can start learning some Japanese. I'd like to be assigned to a space station mission in the future where I get to travel to Japan, and learn about the experiments that they're going to do in their laboratory, Kibo.
Hint to management, yes. Well, let's see, actually the Kibo is an extensive and complex addition to the International Space Station. Let's take a closer look with NASA Payload Mission Manager Scott Higginbotham.
The Japanese experiment module is named Kibo, meaning hope. Kibo is actually made up of 5 major segments delivered to the International Space Station over the course of 3 space shuttle missions. The diverse elements making up Kibo will allow the space station crew to conduct experiments both inside in microgravity and outside in the direct exposure to space. The larger of the 2 pressurized modules will serve as the working laboratory. A smaller pressurized logistics module that sits atop the laboratory will be used primarily for storage of tools and supplies. On the outside are 2 more segments, the exposed facility to hold experiments and a logistics platform. The final piece is a robotic arm attached to the laboratory. The arm will allow astronauts inside the lab to access external facilities and experiments. Attached to the space station's Harmony module, the arrival of Kibo greatly expands the scientific work of the orbiting outpost.
Well, as luck would have it, we happen to have a model of Kibo here. Yep. And let's just kind of go through in general what's up there now and what's not.
Well, the only thing that's up there right now is the logistics module, which was launched on the last mission. To set the scene here, the space station is flying this way, and the space shuttle is docked here. And this module is attached to the Harmony node, node 2, on the zenith, on the upper side of the station. Once Kibo is brought out of the space shuttle's payload bay, it'll be attached to the port side of the space station, traveling this way. And then they will move this logistics module from the top of Harmony and stick it on top of Kibo. This piece will come up later on, next year I think it is, and represents external experiments that will be done using the vacuum of space. It's a pretty harsh vacuum, but very, very good for materials science and for studying the properties of new and modern materials. There's an arm mounted on the Kibo that's going up on this shuttle, on Discovery, and it's 30 foot long. It will be used to manipulate the experiments that are out here on this pallet. In addition, there's a scientific airlock in the middle there. And it's not an airlock that lets humans in spacesuits do EVAs. It's an airlock that allows experiments here to be passed out and put on the pallet using the arm, or brought back in through the airlock to be used and studied by the astronauts that are inside.
And just for clarification's sake, and people were wondering, we were taking up the main part of the robotic arm, 6 foot extension to it will be added on another flight next year.
And that's called the fine arm, and it's much more dexterous. It's more detailed work that it can do and it's carried at the end of this 32-foot arm.
Let's see, this is actually a very good time for us to go to questions that people have submitted on our question board at nasa.gov, so I'll jump right into it and say, the first one, Robert from Ontario asked, how many hours of EVA training are required for every hour spent outside the station on an actual spacewalk?
Roughly about 7 to 1 or 10 to 1. So if you're going to do one EVA on a space shuttle mission, to build something, do some of the space station assembly or get an experiment out there, it would take roughly 10 times the 6 hours of the EVA, about 60 hours or so, 70 hours of training.
And we train in big pools.
Yeah, and of course that training, we forgot to mention that that's in a big water tank, a huge water tank, where a large part of the space station is submerged, full scale. And then we work in there, in that water, in spacesuits, as if it was weightless. But of course it's not. We can feel weight inside the suit. But our bodies basically move as if they were in space.
Let's go to the next question. Bill from Ann Arbor asked, are there any plans to lengthen crew stays on the International Space Station so that we better understand what astronauts will experience on a future journey to Mars?
6 months is what we do on the space station. I've lived on the space station 6 months. That is good enough to get to Mars and get back from Mars using chemical rockets. It's possible that we might go slower, but I think it's unlikely. And in that case, yes, there would be value in extending the missions on the International Space Station. But right now, no plans to do that.
Well, let's see. We've actually been getting a lot of other questions for something that really is not part of the original cargo for Discovery, but we added some pieces for the International Space Station this week. People have heard about. We have a partially working toilet on the space station. And we added some parts that we'll be taking up, including a pump to help that. The fact is, you, my man, have actually used the facilities there. So, just briefly, how do you, again, we get to ask this all the time.
The toilet is really, really a key part of the space station. It's terrible if a toilet breaks because it makes life very difficult. The big issue, the great advantage of being in space, of course, is that it's weightless. You can do experiments with that environment that you can't do on Earth. But it has its complications, and especially for the toilet. And the key is that urine, in this case, is a liquid. It forms a nice yellow ball if you put it out in the open. It shouldn't be. It'll wobble and stick together through its surface tension. But if you try and get it into a bag or into a tank, it won't go. It's going to stick to walls and it won't move. And so the toilet specifically has a vacuum cleaner type of arrangement where it blows air through tubes and tries to get that liquid air mixture to go in towards a tank. Well, how do you get the liquid to go into the tank and the air to separate? And that's what's called a liquid air separator. It's like a centrifuge in a way, and peels off the liquid in one direction and the air in the other. And that's what failed, and that's what's being delivered now on this shuttle, Discovery, to help the crew that are on board the station right now.
I guess if you had to have this happen, it's not bad to have it right before a shuttle flight to bring parts up.
That's true, yeah. Otherwise, you could be doing a lot of maintenance. In fact, we should say right away, they can go to the bathroom. It's just using a lot more water than they normally do, and it's a lot more complicated because they're having to do extra flushing, basically, to keep the urine in the right place.
But these are the kind of things we have to develop on the fly and
Absolutely,
be able to do for long
yeah.
flights. So.
Living and working in space, you're learning all kinds of stuff about how the pumps work, how they don't work. You're learning about how to make machinery and equipment work that would allow us to do colonies in space, for example. Live for a long time, not just 6 months. Same technology will be used going to Mars, and the same technology or similar technologies will be used on the Moon and then Mars when we have colonies there.
All right, well, that's an interesting way to leave us, and I do appreciate you joining us, and thanks for stopping by, Mike.
Thank you. It's a pleasure.
And tonight at about 8:30 p.m. Eastern Time, the rotating service structure, the protective covering for the shuttle at the pad, will be rolled away from Shuttle Discovery, and liquid oxygen and liquid hydrogen are set to begin flowing into that external fuel tank a little after 7:45 a.m. tomorrow. Right now, the weather forecast calls for about an 80% chance of good weather, so fingers are crossed, and we'll keep looking towards the sky. To follow the launch countdown, tune in live to NASA television or click your way over to www.nasa.gov/shuttle to find NASA's launch blog for online play-by-play of the action leading up to the liftoff of Space Shuttle Discovery and the start of the STS-124 mission. I'm Allard Beutel. Thanks for watching. At T-minus 11 hours in holding, this is L-1.